Good evening once again. Good evening, friends. Uh, Today we are starting with the new topic. Guess what it is? It is center of mass. Okay. Um, there are some queries saying that should the center of mass of an entity, of an object, should it always be at the center? Or can it be at different places? And in fact, one of the students said for an equilateral triangle, center of mass should be at the center. Now, the question is not about equilateral triangle, but let us look at the problem. Okay, there are multiple methods over here, only one method we have. Let us see this. Three particles of masses 1 kg, 2 kg, 3 kg. By the way, I am not going to define center of mass. I expect you people to go through the definition. Okay, so I am directly jumping on to the problems. Three particles of masses 1 kg, 2 kg, 3 kg are placed at the corners of an ABC of an equilateral triangle ABC. See, now this is the question. So usually when this problem was given to students, what they did was they wrote an equilateral triangle. They forgot to write this ABCs here. Okay, and suddenly what they did was they should be at the centroid. That's what they thought. Okay, so centroid is nothing but at this point, maybe at the orthocenter, in center, centroid, in an equilateral triangle, everything coincides, right? So they thought maybe it would coincide at this point. Now let us see from the student perspective, what could be the answer they would have got. So they would have got edge of 1 meter. This is 1 meter. This is 1 meter. So this should be, let me say D. So this should have been half meter, half meter. So definitely this should have been, let me say this is AD is X. AD is equal to X. So then I have X square plus 1 by 4 is equal to 1. This implies X square is equal to 1 minus 1 by 4, which should be equal to 3 by 4. This implies X should be equal to root 3 by 2. Okay, so if this is root 3 by 2, we know that the point G, which is the centroid, in this case, okay, divides this base, divide this whole thing in the ratio of 2:1, right? The distance from point GD should be 1 unit, and here it should be 2 unit, something like this. So as a result of it, now if this whole length is equal to X, then I can now say something like 2y. Let us say this unit is y, this unit is y. Okay, then 2y 2y plus y 3y should be equal to root 3 by 2, or y should be equal to 1 by 2 root 3. Okay, and then suddenly then they said that, okay, if I consider this as my y-axis, this as my x-axis, then you know at this point this will have a coordinate equal to half, and upward coordinate I already determined, this is y, right, which will be 1 by 2 root 3. Thus the center of mass coordinates should have been half comma 1 by 2. Seems to be very simple, and we have really got it. That's what people think. Okay, but the solution is incorrect. Why incorrect? And what is the correct solution? So it is incorrect because you have not located, you have not used the concept of masses anywhere. Okay, so each one of them have a different mass here. This is having a mass of 1 kg, it's having a mass of 2 kg, it's having a mass of 3 kg over here. The center of mass tells you that somewhere you need to use the masses. You have several masses distributed at several points, and then you need to use, okay, these masses and finally find the coordinate. Here what you have done is you have not used the masses, you have just drawn lines, and you have thought, okay, these lines are of uniform weight, and finally you found out what is the center of mass, which is totally incorrect. Okay, here you have just found out the center of the triangle. This is not the center of mass. This is a misconception. Okay, now let us start working. Now the center of mass is defined by the formula XCM is equal to M1x1 plus M2x2 plus M3x3 divided by M1 plus M2 plus M3. In a similar way, YCM is defined as M1y1 plus M2y2 plus M3y3 divided by M1 plus M2 plus M3. Now you can ask me why three coordinates you are taking. The reason is because you see you have three vertices over here. Okay, three nodes over here. As a result of this, as a result of it, definitely we need to take three coordinates. Okay, done. What's the next step? I do not know anything about x1, x2, x3. That's a question you have. So towards it, what you do is you consider the point B to be the origin. Okay, or origin, and this is one of the vertices of it. Now let us start doing it. Let me consider this is my, yeah, I take an A here, right? Okay. Let me consider this is my x1, y1. X1, y1. What is x1, y1 now? Where shall I write this? Just a moment. I'll write it on here. X1 comma y1 is equal to 0 comma 0. See, at this point, at point B, this is point B, which is 0 comma 0. Now what is x2, y2? X2, y2, which is, let us say, which point shall I consider? C. Point C, I'll consider. Point C. This should now be, what is this point now? This point is now 1 meter away from here. 1 meter. And x2 is got. Y2, what is the value of y2? Y2 coordinate is 0. 1 comma 0. And what is the next coordinate? A. B, C, A. This is x3 comma y3. x3 comma y3, which should now be equal to, what is this coordinate here? This coordinate, what is the coordinate here? See, this is 1 unit. Okay. Now this coordinate we already found out. See, this our students have done this wonderful work. Okay. This is seen to be, that is it. I assumed. Okay. So this is nothing but 1 by 4 plus 1. What is this? 1. Sorry, 1 by 4. 1 minus 1 by 4. Root 3 by 2. Okay. This value is root 3 by 2. X value is half. And Y value was root 3 by 2. Okay. Now we have got all the coordinates. Now let us substitute. Simple. Right. So your XCM now becomes M1. What is M1? Okay. Let me choose this as my M1. This is my M1. And since M1, I am going to multiply here. M2. See, second coordinate. So this is my M2. This is my M3. What is M1? M1 is 1. M1 is 2 kgs. Okay. 2 kgs multiplied by X1. What is X1? X1 is 0. Good. Plus M2. What is M2? M2, 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 M2. I have written here 3. 3. 3 multiplied by what is X2? X2 is 1. Plus what is M3? M3 is this one. What is mass here? Mass here is, I have given the brackets. This is 1. 1 multiplied by X3. What is X3? X3 is half. Half divided by M1 plus M2 plus M3. 2 plus 3, 5 plus 1, 6. Okay. Now let us solve this equation. What do I get here? This is 0. This is 3. This is half. This is 3 plus half divided by 6. What is 3 plus half divided by 6? 3 plus half is 7 by 2. 7 by 2 divided by 6, which should be equal to 7 by 2. I got the answer for XCM as 7 by 2. See, what did we get earlier? What did the student got? Half. Right? Incorrect. Now let us look at this one. YCM. What do we get for YCM? Okay. YCM. For YCM, YCM is equal to M1. What is M1 once again? This is M1. What's the value of M1? M1, M1, M1. Where is M1? M1. See, I have used M1 equal to 2 here. I'll use the same value. Don't change anything. Okay. Into Y1. Y1 is 0 once again. Origin. Plus M2. What is M2? M2 is here. What's the value? 3. 3. 3 multiplied by Y2. What is Y2? Y2 is 0. Wow. See, it becomes easier. M3. What is M3? M3. M3 is 1. 1 mass, 1 kg. See, I put 1 kg, 2 kg, 3 kg. 1 multiplied by Y3. What is Y3? Y3 is, what is Y3? We wrote this somewhere here, right? Yeah, root 3 by 2. Root 3 by 2 divided by 6 once again. How? 1 plus 2 plus 3. Simple. Okay. So now this should now be, this is totally 0. So you get root 3 divided by 12. Okay. So thus, what is your final answer? XCM comma YCM should be equal to 7 by 12 comma root 3 by 12. Got it? So this should be your answer. Okay. So as the values change, this will also change. Okay. So which means, so now what is center of mass? First of all, I just focus on it a little bit more. So what you do is, if I have 3 masses, 1 kg, 2 kg, 3 kg here, And let us say, for example, I somehow build a connection between them. That means I let us say there's a hook here, okay, and I join a thread here, like this. I join a thread here, okay, and then or maybe yeah, okay, and then what I do is at the center of mass, wherever you have at the center of mass, let us say 7/12 will be equal to how much? Will be yeah, 7/12. What is the value of 7/12? Let me calculate this. We just take some value. 7 divided by 12 is 0.58. And what's the next step? Root 3 by 12. 1.73 divided by 12 is 0.14. So you should get 0.58 comma 0.14. 0.14. So at these coordinates, okay, you can locate it somewhere over here. 0.58 would be somewhere over here. 0.12 would be somewhere over here. So this point, for example, okay, so there, if suppose if I have a plane lamina, if I had a plane lamina like this, wherein the three masses are concentrated like this, then at that point, okay, not in centroid, at that point, if I keep a fulcrum, then the object would be exactly supported. Okay, so that means the entire mass of the system is being focused at this point. I hope you understood about this. Like, what do you mean by center of mass? In the further videos also, we'll look at how to calculate center of masses in different scenarios. Okay, and what are the typical misconceptions or mistakes which the students do. Thank you, friends, for watching this video. If you like this video, do like, share, subscribe to my channel. This would really help me to post many videos. I can also get to know about you. So this is what it is. Thank you. Thank you. You can visit my website to know more about me, and you can mail me if you have any problems, or you can directly post it on YouTube to get to know more about it. All my other videos, okay, are completely in this website. You can visit this website to access those videos also. Thank you, friends, for watching.